of the following cases. So, all right, so we need to, all right, so we have here 1, 2, 3, 4, 5. All right, so we have here, so in the first case, all right, we have just a box on the surface. All right, there is no other force involved. So what are the forces that act on the box?
Only 4 kilograms.
So the mass of the box is 4 kilograms, right?
Right.
But what are the forces that act on this box?
Downwards.
So first we have a force, the mg, right? The weight,
Right.
mg, right?
Right.
It's the mass times g times the constant g, which is 10 meters per second squared. Okay.
What does it mean, כוח הנורמלי?
Koach normally means the normal force. When we have a object on a surface, so the surface is going to apply a force on this object, and this force is called the normal force, koach normali. Okay,
Right.
and this force, the normal force, what's important to know about it, that it's always perpendicular to the surface that's applying it. Okay.
Okay.
So look, we have a force mg down here. Okay, down. Do we have any other force?
Yeah, the
applied to
one
box?
up, the normal force, upwards, no?
The normal force upwards, right? Because otherwise it would accelerate downwards, right?
Right.
If we wouldn't have the normal force upwards, this box would accelerate downwards. So we must have this normal force upwards, right?
And this is stati?
No, it's stati. We talk about stati when it comes to friction. This is not friction, okay?
Okay, no problem.
So this is then just the normal force, okay? It's just the force. I mean, what's keeping the box from accelerating down? It's the table holding it, right?
Right.
So this table is like applying a force. This force, it's called normal force, okay?
Okay. And how do we find the normal force?
So what do we know? So we know that N must be equal to mg, right? Because this box is not accelerating, right?
Right.
So N, the normal force, must be equal to mg, okay?
Yeah.
So if the normal force equals to mg, so we can write...
How do we find out that how much 4 kilograms is in mg?
What's that?
I'm guessing the 4 kilograms is equal to the mg. The 4 kilograms.
No, 4 kilograms is just the M. This is the mass, okay?
Right.
The mass is 4 kilograms, okay?
Right.
When we talk about weight, you know, in daily life, when I say my weight is 80 kilograms, so it's not physically true. I mean, in physics, my mass is 80 kilograms, not my weight. The weight
Right.
is the force, which is mg, which is the mass times the constant g, okay?
Okay.
So the mass is 4 kilograms, the constant g is 10, right, or 9.8, right?
Right.
So the normal force is going to be equal to...
So sorry if I'm stopping you. So mg equals 4 times 10.
Right, mg is 4 times 10. And mg is not kilograms, the force is in newtons, right? So mg is 40 newtons, okay? The
Yes.
mass is kilograms, but the force is newtons. So the normal force is going to be 40 newtons, okay?
How do we know if it's N for normal or N for newtons?
We don't.
Hmm.
So look, if it's... yeah, I mean, it's confusing.
But okay.
All right. All right, second case. So here we have a box on the table, okay? But now we have a force. I mean,
That's
it's
of
10
10 and upwards.
Yeah, it's a 10 Newton force. Don't confuse it with a normal. The N here means 10 Newton force acting on it, okay? There is a force here of 10 Newtons upwards, okay? That's acting on this box. And we need to find what's the normal force, okay?
Yeah.
So how can we find the normal? So first thing we do, what are the forces that are acting on this box? What are the
4
forces?
kilograms and 10 newtons.
Yeah, so 4 kilograms is the mass, right?
Right. So we said
the mass.
That's
So
40 mg.
right? Yeah. So first thing, so we have the mg down, right?
Right. So
And
I will do
we
40
also
minus
have,
10. No,
what's that?
I will do 40 minus 10.
Very good, right? The normal is also, and we are also going to have a normal upwards, right? And we need to find the normal. So now we can do the equation that,
But sorry, I'm asking. The question is, what is the كوخ شسمه مشتق, right?
yeah, that's the normal force.
Uh-huh.
That's the normal force, okay?
Yeah.
Because what's causing this normal force, it's what's applying this normal force, it's the surface, okay?
Mm-hmm.
So now the equation is going to be mg equals the normal plus 10 newtons, right?
Yes.
Equals the normal plus 10 newtons, okay? So
Right.
now, so the normal is going to be,
mg equals 4 times 10.
yeah, so the normal is going to be mg minus 10, right? So the normal is going to be 4 times 10 minus 10. So the normal is going to be 40 minus 10, which is 30 newtons. Okay?
Yeah.
Very good. All right.
So n equals 10.
Yeah.
Okay. Now the next one, it's
Next one.
adding force.
What's that?
It's adding force. So it's like mg equals n minus 10.
So let's see. So let's just do the equations. So what are the forces applied here? So we have mg here, right?
Right.
So mg and a normal. Okay.
Right.
So let's do the equations. So we know that so the forces must be balanced because this thing is not accelerating. So what we can say is n equals mg plus 10, right?
Right. mg plus 10 equals n. Yes.
Yeah. So n equals 40
Plus 10.
plus
Right.
10, which is 50. So n equals 50 newtons. All right. Next one. So what are the forces applied? On the next one.
Yeah. So now we're gonna have to use cosinus, no? Or sinus.
No, here, this one before.
Oh, sorry. I didn't see that one. So this one, it's on the side, right?
Right. So what we are going to have on the y-axis, we are going to have mg here and the normal here. This is what we are going to have on the y-axis, right?
Right.
And what's the equation that we can write? So the equation that we can write is mg equals n. Okay. So 40 equals n. All right. This is the equation that we can write. So this is on the y-axis. So on the x-axis, it's going to accelerate, okay?
Yeah.
On the y-axis, sigma f equals 0. The sum of the forces is 0 on the y-axis because it's not going anywhere on the y-axis, right?
Yeah.
All right. Now, let's see number 5. So what can we do on number 5?
Wait, so ymg equals n. So y n.
On the y-axis, mg equals n. Yeah.
And what about the x-axis?
On the x-axis, it's going to accelerate. So we have on the x-axis, we have a force of 10 newtons to the right. So it's going to accelerate.
So it's good. So x is equal 10 newton, 10 normal.
Yeah. So it's going to have some acceleration.
And
the force on the x-axis is going to be 10 newtons.
okay, so xn equals 10.
So look, so fx, fx, the force on the x-axis is 10 newtons, right?
Yeah.
So then, if we do on the x-axis the forces, so it's not going to be sigma f equals 0. It's going to be sigma f equals ma. Right? Because on the x-axis,
This is Newton's laws.
Newton's law, right?
Right.
So on the y-axis, we know that it's not moving anywhere. Okay. On the
Right.
y-axis, it's just at rest. Okay. But on the x-axis, it's not necessarily at rest. So what we can do, so sigma f, so we can do 10 equals ma. So 10 equals, the mass is 4 times a. So a equals 10 divided by 4. Okay. So the acceleration is 10 divided by 4. Okay, so how much is 10 divided by 4? It's 5 divided by 2. It's 2.5, right?
Yeah.
So A equals 2.5 meters per second squared. This is the acceleration on the x-axis.
Right.
Okay.
But that's not the normal force. This is only the acceleration.
Yeah, there's acceleration. It's not the normal force. The normal force we already found. It's 40.
So yes, but what do we do with the? So there's no normal force on the x-axis.
Oh, normal force is always perpendicular to the surface. So the
Mhm.
normal force is always going to be 90 degrees to the surface. It's going to be.
I got it. 100%.
All right.
Yeah.
Very good. So next one.
Number 5, we're gonna have to use vectors, no?
So yeah, we have to use the sine and cosine, right?
Right.
So first, let's do all the forces that act on this box. So we have mg downwards, right?
Right.
Mg downwards. We have a normal upwards. And then we have the force of 10 newtons. And what we want to do, we want to separate it into two components, the x component and the y component, right?
So y.
So what's going to be the x component? What's that?
The y. Oh no, wait, because it's okay. Never mind. Yeah, sorry.
Yeah. So what's the x component going to be?
I have to use here sinus, no?
So the x component is adjacent to the angle. Okay. So I use cosine. When it's
Cosine.
component that's near the angle, I use cosine.
So
This is
cosine
gonna be,
30.
yeah, 10 cosine 30. Okay. And then the y component is going to be 10 sine 30. Okay, because this is the against the angle. This is going to be 10 sine 30.
So 10 cosine is 30.
Yeah, sine 30 is half. So 10 sine 30 is going to be 5. Okay, so this is going to be 5.
Wait, I'm sorry. I'm writing first the cosinus.
It doesn't matter what you write first. All you need to know is just that the adjacent, the component that's near the angle, adjacent to the angle, it's going to be cosine. Okay. The component that's against the angle is going to be sine.
So 10 cosine 30 equals 8.66.
All right. So this is 8.6.
Yeah.
All right. So this is 8.6 newtons. All right. Now let's do, to find the normal, we need to do the Newton's law on the
What is the sine?
What's that?
Wait, and with sinus, what do I do? How do you know it's 5 normal upwards? How did you do?
Sine 30 is half.
10
okay?
since, yes.
So 10 sine 30 is going to be half of 5. So it's going to be f of 10. So it's going to be 5.
Yes,
Right.
okay.
So, all right. So now let's do the equation. Let's do Newton's formula. So on the y-axis, we know that sigma f equals 0, right? Because the box is not moving. Okay. So sigma f equals 0. So mg must be equal to 5 plus n, right?
Yeah.
Mg equals 5 plus n. So n equals mg minus 5. So n equals 40 minus 5. So n equals 40 minus 5. So n equals 35. newtons. Okay.
Yeah.
So this is M.
Wait, sorry, I'm just trying to do it because you're right, and also I'm trying to understand so I know, It's
Yeah, it's a very important one. I mean, you must understand.
yeah.
So you see what we do here?